Hello, my name is Dr. Alol Navidan. I'm Neurology Residency Program Director at UCLA and also Associate Director of the UCLA Sleep Disorder Center. The program today is focusing on sleep disorders in residency training and specifically addressing sleepiness and specific countermeasures to counteract the fatigue and sleepiness associated with residency training. To begin, there are several domains that we need to appreciate. One of the hallmarks is really the effect of sleep deprivation on training, professionalism, and the associated safety issues with performance while in the hospital, duties associated with residency training, fall asleep accidents, and really addressing specific countermeasures to counteract sleepiness and education about sleep hygiene and specific education about circadian rhythm physiology and countermeasures to counteract the effects of sleep and fatigue. To begin, there are prevailing myths that one can appreciate. Many residents feel that coffee and determination will help them fight sleep deprivation. Napping makes no difference, and a good night's sleep will help them feel rested. They can learn how to adapt and get by less sleep, and they can tell when they're getting too tired. And in fact, many of this, and in fact all of this, are really myths. Determination, unfortunately, is not going to help that much. Napping can be actually very helpful if it's taken strategically in the afternoon hours between 2 to 4 p.m. And just remember, sleep is not like a bank. You cannot take a few hours of sleep one day and then combine it with a few hours the next day and combine it and say that you have slept enough. That's not going to work. You cannot learn how to adapt, and unfortunately, sleep is not something you get without. You need sleep. It's physiologic. It's not something that is negotiable. And the last thing is you can't really tell subjectively when you get too tired. The ability to self-perceive sleep deprivation is very poor. Having said that, I'd like to just make the argument that the delivery of medical care in the U.S. is a 24/7 function, and really we need to focus on the management rather than the elimination of fatigue as a driving force when we appreciate the interface of sleep and residency training. And I'd like to address a few alertness management strategies that can be quite helpful. First, how much sleep do you need? Well, 7 to 8 hours for the average adult is needed to sustain optimal alertness. Unfortunately, when you don't get enough sleep, that's what you get. And many post-call residents feel very much like the guard who fell asleep irresistibly. To understand the effects of sleep deprivation on human performance, you need to appreciate that without sleep, our cognition is low, memory problems can occur, as well as perceptual alterations, poor reasoning and judgment, attentional deficits, and decreased informational intake. This is really a non-executive component of cognition. And with that, we can also appreciate some endocrine function. Recent data shows that sleep-deprived individuals have an increased levels of ghrelin, which is an appetite stimulant, accounting for the increased body mass index associated with sleep deprivation in humans. The causes of sleepiness in residency are multifactorial. By and large, the majority of residents are experiencing sleepiness due to insufficient sleep, inadequate recovery from sleep loss, fragmented sleep while on call. Even the anticipation of being on call can disrupt sleep architecture, and not to mention the fact that you get calls and pagers and interruptions during the night. On top of that are comorbidities like primary sleep disorders, mood disturbances, medications, and circadian rhythm factors such as rotating shifts and night floats in specific residencies. Let me just show you a hypnogram. On top you can see a normal hypnogram in someone who doesn't suffer from sleep deprivation. Y-axis shows a sleep architecture, awake REM, non-REM sleep, and slow wave sleep, and you can see a very nice progression through the sleep cycles with time. On the x-axis you can see 8 hours of sleep, and on the bottom you can see sleep disruption in a post-call or on-call resident rather, and you can see that each one of the clocks represents a pager going off, and sleep is very fragmented, very disrupted, and at the very end of the night shift the resident has to go to morning report, and of course they're very sleepy. Let's go over some of the basic physiologic aspects of circadian rhythm derivation. Let's talk about sleep physiology. As you remember, and you all know that humans have evolved to work in a 24-hour cycle due to recent technological advancement. We're not really genetically programmed to work during the night. Some species are, like the nocturnal species that can do very well at night, but we, unlike lemurs, can't do very well because we're genetically programmed to work and be alert during the daytime. Let's go over the basic concepts of how the circadian rhythm is derived. Remember that light on the left panel, light is perceived through the retina, the retinal hypothalamic neurons that carry the impulse of light to the suprachiasmatic nucleus, the SCN, which is residing just above the optic chiasm, and it keeps us stimulated during the day. Light is wonderful to have because it keeps us alert. During darkness, there is inhibition of the SCN. In fact, melatonin is secreted by the pineal gland, and melatonin attenuates or inhibits the alerting effect from the SCN. And this is what happens. During the daytime, you can see wake propensity is quite high, and we get our maximal effect just around 9 p.m. And right after 9 p.m., melatonin is secreted. As you can see, melatonin secretion attenuates the wake propensity, allowing us to fall asleep very nicely. But unfortunately, this is the time in which you're supposed to be on call. So when we plot the alertness curve, and you can appreciate that between 9 p.m. to 9 a.m., this is when physician work hours have to take place, in which time the drive for wakefulness is at its lowest and drive for sleep is at its highest. And with that, we can see that error rate, sleepiness, psychomotor vigilance are all associated with sleep. Sleepiness is highest between the hours of 12 noon to about 6 a.m. We also see reduced psychomotor vigilance, cognitive throughput, recall, and memory are all disrupted. Interestingly, the rates of accidents go up between 12 midnight to about 6 a.m. Bhopal, India, 3 Mile Island, Chernobyl all took place during those selected time of a selective vulnerability where our alertness is at its minimum. And in fact, the rates of car accidents, motor vehicle accidents are highest between 2 to 4 a.m. Now, let me just show you sleep deprivation expressed as blood alcohol equivalent. You can see that with a 24-hour of sleep deprivation, the studies show that this is equivalent to a blood alcohol level of 0.1, which is about 4 servings of alcohol in a 150-pound male. Also, associated with sleep deprivation in residency, you can see increased sleep inertia. Sleep inertia is defined as the period of time of incomplete arousal following awakening after prolonged sleep deprivation of less than 3 hours, judgment is reduced. There is also poor judgment, impaired recall, and often inappropriate decision making. And the national survey data shows with sleep deprivation, the residents are at increased risk for conflicts with colleagues, mistreatment of patients go up, dissatisfaction with the learning environment, as well as increased risk for stress, injury, and increased use of alcohol and stimulants. In fact, the odds ratio of residents averaging less than 5 hours of being involved in malpractice goes higher, and also with that comes the higher rates of serious conflicts with others, accidents, noticeable weight gain, which can be related to the ghrelin, increase in ghrelin as an appetite stimulator, as I've mentioned earlier, and also serious conflicts and degradation of professionalism when it comes to work with your colleagues. How can you tell? What are the clinical signs of sleepiness? Well, first is falling asleep inappropriately in lectures. Hopefully everyone is paying attention as I'm speaking, but you can appreciate residents yawning. There is paucity of movement, difficulties keeping the eyes open, and poor concentration. There are also frontal release signs such as apathy, impoverished speech, flattened affects, inflexible thinking, impaired planning, inability to think in a novel fashion, and multitask. There is also evidence for microsleep, which are a few seconds in duration, causing lapses in attention, nodding off when sedentary. In fact, you can be taking notes and you notice that you begin to write gibberish as you're having the microsleep episodes. There are also REM, rapid eye movement phenomena such as hypnagogic hallucinations and sleep paralysis. So how can we manage sleepiness? I think that's really the key. The first is appreciating that in order to reduce the impact of sleep loss, you just need to sleep. You need to appreciate that the circadian rhythms and sleep need are non-negotiable. You can't get used to sleep loss. You can't make up for lost sleep. Sleep is not like a bank. You need to get up and go to bed at the same time every day. You need to develop a pre-sleep routine. You need to encourage yourself to use relaxation techniques. If you can fall asleep readily, get rid of the iPad. Don't use computers before going to bed, because the blue light from the computer is actually stimulating the SCN and causing you to be more awake. Making sure that you get 7 to 9 hours before the anticipated sleep loss while being on call. Don't start your call night sleep deprived. And you need to enlist the help of your family members, friends, loved ones to help you work through this change in schedule. Secondly, you need to avoid, as I've mentioned, starting your call sleep deprived, but also remember that even when you're on call, you may have also a bad night, even though you may not be up all night. Just the anticipation of being on call is enough to cause you to get reduced sleep. And really the bottom line here is to make sure you get 7 to 9 hours before the anticipated sleep loss while on call. Recognize the warning signs of sleepiness: falling asleep in conferences, rounds, feeling restless, irritable, both with colleagues, family, and friends, having to check and recheck your work repeatedly, having difficulty focusing on the care of your patients, and feeling like you really just don't care anymore. There are specific countermeasures like planned naps between 15 to 20 minutes every 2 to 3 hours while you are on call or post-call. CNS stimulants in the form of caffeine can be very, very effective. Bright light early in the morning can help consolidate sleep, especially if you have to transition to a different call schedule. Bright light can really help drive the SCN, the suprachiasmatic nucleus, to reestablish a normal circadian rhythm. Let's talk about the advantages and disadvantages of caffeine. First, caffeine is readily available. Let's face it, every corner of Westwood, and whenever you walk around the campus here at UCLA, there is a coffee store. It's readily available, you can get it at any time, and it's quite effective even at lower doses of 75 milligrams. Just to give you a comparison, a can of a Diet Coke has about 50 milligrams of caffeine. Drip coffee has a little bit more, 75. Starbucks and other gourmet coffee have between 200 to 400 milligrams of caffeine. It can be used on demand. The onset is 15 to 30 minutes. The half-life of caffeine is about 3 to 7 hours. You can use it on demand for the temporary relief of sleepiness. Very effective, available, and accepted. It helps boost alertness, but there is there is a downside, of course, that if you use caffeine too close to the bedtime, you may see negative effects on its sleep architecture, frequent arousals and awakenings, and it can cause insomnia if you take it early in the afternoon and in the evening time. And also, caffeine is a powerful diuretic, so that's not very good for sleep architecture. So really, strategic consumption is the key. Post-call and before driving back home after being on call. Strategic napping is really the only definitive way to reverse the physiologic need for sleep. And the way to do it is to ensure that you work with your program directors to make sure you have a quiet, clean, comfortable, and a place where you can access the call room at any time. And you need to schedule your sleep according to your work schedule. So perhaps after being on call, if you need to do a little bit more work and you feel sleepy, that's a good time to take your power naps. And also remember when I showed you the alertness curve and you remember the dip between 2 to 4 p.m., another way to use the power naps is to strategically intervene with taking the naps when your alertness curve is at its minimum during the night and in the early afternoon. Prophylactic naps, again, as short as 15 minutes, can help ameliorate performance decrement significantly. Drowsy driving. What works? Well, first, avoid driving when you feel sleepy. If you can get by with taking public transportation, do that. Make sure you choose a place, your apartment, close to the hospital if you can. Have some caffeine before driving if you feel sleepy. If you're driving and you notice that you're feeling drowsy and sleepy, make sure you pull to the side of the road. Take a short nap if you're in a safe place while pulling off the road. What doesn't work is really pinching and slapping yourself or turning up the radio, opening the car window. Those of you from the Midwest and East Coast, well, if you open the car window in the middle of January, maybe that will help. But here in California, it doesn't really do it. Blowing cold air or water on your face doesn't work. Pinching yourself doesn't work. And unfortunately, promising yourself a reward for staying awake doesn't really do it, unfortunately. How to survive a night float for those programs that institute a night float system. Again, what really works is protecting your sleep, napping before work, having exposure to bright light when you need to be alert. And let's say you finish your call, your night float, and you need to go home to sleep. You need to avoid light in the morning and use sunglasses while driving, so the light doesn't stimulate your SCN to the point that now you can't fall asleep. I just want to conclude by one hypothesis, which is using the Swiss cheese model to describe errors, in that the more barriers you have, the more nicely they align to prevent errors from occurring. You have the sleep-deprived resident, and hopefully you will see that the more interventions we use, work hour regulations, caffeine, night float system, using power, planned naps can all align themselves to prevent the error from occurring. So the more barriers, the more safety interventions we use, the less likely we are to see poor quality of life from sleep deprivation, accidents, and errors. So what I've shown you is that fatigue is an impairment just like alcohol and drugs, and really the effect of sleep deprivation in residency is not something that is here to stay. You can certainly learn to use specific countermeasures, wake-promoting psychostimulants, caffeine, and despite the fact that sleepiness and fatigue cannot be eliminated in residency, it can be managed very well. So I hope this was informative, and thank you for your attention.